Okay, we're going to keep going with multi-step equations, and today we're going to talk about when you have variables on both sides of the equal sign. Okay, variables on both sides of the equal sign. So if you look at number 1, okay, what does it have on both sides of the equal sign? Variables. Okay, we only want to have a variable on one side, right? I don't want h's over here and over here because I'm trying to get it just to h equals something. So I'm going to undo subtracting 5h by adding 5h. Okay, I put it underneath here because these are my like terms. So when I combine it, right, that's where it's going to go. So now, over here, I have 7 plus 3h plus 5h, which is 7 plus 8h equals negative 1. Okay, now it should look super familiar. Subtract 7, subtract 7. Oops, 8h equals negative 8. Divide both sides by 8, and we get h equals negative 1. Okay, and let's see what happens if I plug it in. Okay, that would give me, I'll use this pink color, 7 plus negative 3, so minus 3, right? So what is that? That's 4. Negative 1 minus 5 times negative 1 is negative 5. So 7 minus 3 is 4. Negative 1 plus 5 is 4. So I know I got it right. Okay, let's look at number 2. Before I can do anything else, I have to go ahead and do, sorry, my chair is squeaking, do my distributive property. So 5 times x is 5x minus 5 times 12 is 60. And that equals negative x. So I don't want variables on both sides. So it doesn't matter whether I add x over here. Actually, let me go ahead and I'll do that. I'll do it this way. Okay, so let's add x. So over on the left now, I have 5x plus x, which is 6x, minus 60. What's left over here? Is it just empty? It's 0. And so now we're going to add 60 to both sides. It's just a two-step equation. So 6x is 60. And then when you divide by 6, oops, x would equal 10. Okay? And look, if I put it in here, 10 minus 12 is negative 2. 5 times negative 2 is negative 10. That should equal negative x, negative 10. Let's look at number 3. Okay, distributive property again first. So we get 4x equals 2 times 3x is 6x plus 2 times 9 is 18. Okay, I only want variables on one side, so I'm going to subtract 6x from both sides. 4x minus 6x is negative 2x equals 18. Then we're going to divide both sides by negative 2, and I'm left with x equals negative 9. Okay, why don't you try, okay, just try 4, 5, and 6, and let's see how it goes. Okay, on number 4, the first thing you should have done is the distributive property. So 7x equals 9x plus 36. Then we would have subtracted 9x's from both sides to get negative 2x is 36, and then divided both sides by negative 2 to get x equals negative 18. Okay, 9 times x is 9x, 9 times 4 is 36. Subtract 9x from both sides, divide both sides by negative 2. On number 5, okay, I'm going to get rid of these 2x's by subtracting them from both sides. So 3x plus 3 equals negative 21. Now I'm going to subtract 3 from both sides. So 3x is negative 24. And then I'm going to divide both sides by 3 to get x equals negative 8. Okay, again, every time, best for last. Keep, change, change, keep, change, change. Okay, if you were wondering, like, why can't you just do 12 minus 4 first? Because of PEMDAS, right? PEMDAS tells us we have to do multiplication first thing. Okay, so I have 12, and then negative 4 times x, negative 4x, and then negative 4 times negative 4 is plus 16 equals 3x. Okay, there's a whole lot happening here, right? So now I can combine 12 plus 16 to get 28 minus 4x equals 3x. I only want variables on one side. I'm going to go ahead and just add 4 x's to both to get it rid of over here on the left. So now 28 equals 7x. I'm going to divide both sides by 7 to get 4 equals x. And if I wanted to plug it in, this is the funny part. If I plug it in, 4 minus 4 is 0. 4 times 0 is 0. 12 plus 0 is 12. What's 3 times 4? 12.